enzyme that is a flavo heme protein or substrate that is nucleotides on basis the simple isotopic exchanges some catalysis sources the isoenzymes are one some group on the basis of type reactions with the name and the substrates subsequently the reactions by one enzyme named on the first enzyme catalyzed step that as for example it is acetyl coenzyme A glyoxylate C acetyl transferase that is carboxymethyl forming. The written direction of reaction used for naming these all type of the characteristics and principles should kept in mind before doing the exact classification and nomenclature. The scheme for classification that how we have to go for the classification for that enzyme commission is required that is been reported that it is been formed 1961 and they have given numbers the exact EC numbers that is enzyme commission number to each and every type of the enzyme which has been identified and nomenclatured that once the name is been given then we have to get the clear idea that it belongs to which class, which subclass, which subclass and so on because many times it happens that the reactions are catalyzed more or less it is same but it is just differing in very small way so confusion to avoid confusion this type of the system is been coined by the enzyme commission the number which is given to them it is for example it is EC 1111 so when we want to understand the name pattern then we can understand that prefix EC that contains the four elements separated by the points with meaning that each 1111 these all one are having some meaning right the first number shows one of the six main divisions when we go further move further we'll understand that there are six major classes that it will be discussed by sir later on so it will be from one of that class so that first number denotes for that second figure indicates the subclass one that is for a class there are six classes for different enzyme groups now any one is of one first suffix is for that then second will be for subclass that it belongs to which subclass third figure gives the subclass the second part of that subclass and the fourth figure serial number is subclass so that way we will move further towards precision when we start EC it denotes that is enzyme commission then first one will come that is class subclass subclass and then lastly subclass that is the latest the final most reaction which is going on so in this pattern we have to give the systematic name to each and every type of the enzyme so from the number also we can understand that which type of the enzyme we are talking about.
So in a way it is more or less like IP address of the computer.
Yeah.
Because there also the naming pattern or naming convention is similar to this like 192.168.100.1 is a BSNL network IP address for internet protocol so similar naming system numbering system was approved for enzyme way back in 1961 and the same under the same naming pattern each one of the enzyme is classified into one of the four categories arranged in a hierarchical manner and that is how distinctively every enzyme can be assigned to a specific taxonomic group so this EC number for example 1.10.3.2 if you feed into the centralized database of enzyme information then probably you can retrieve this kind of information starting with EC number at the top and in the second line you come across accepted name that is trivial name or general name or name which are commonly used so this one is a leakage obtained from the sources like fungi and the lacquer, Japanese lacquer tree like Rus vernicifera, etc. So this is a kind of phenol oxidase enzyme and is more commonly known as lacase. And the reaction catalyzed by this enzyme is 4-benzene-diol plus molecular oxygen giving 4 molecules of benzosemiquinolone and water molecule is released. There are other names also by which the enzyme is known. These names are paraphenol, paradiphenol oxidases or urushiol oxidase. But in addition to these kind of common or trivial name, every enzyme has a specific systemic name. And this systematic name for the enzyme lacase is benzene-diol oxygen oxidoreductase. So you can look into the naming convention applied over here, starting with substrate. And since this is a multi-substrate system, that is, a enzyme is able to catalyze the reaction which involve 2 different substrates, because every oxidoreductase are oxidizing one compound and are concomitantly reducing the another one. So both of these substrates are to be mentioned, and these 2 substrates are to be separated by a colon. So that is how a systemic name of the enzyme has been derived, that is benzene-diol double dot, that is hyphen, and oxygen and oxidoreductase. This is the naming system which has been suggested and approved by the Commission. About this enzyme, additional comments are also listed at the end of systemic name, which says that this is a multi-copper enzyme with a low specificity. That means the enzyme can recognize number of different substrates which are of phenolic nature, and it could be ortho or para or type of quinols, and the enzyme knows no distinction among this type of compounds because it has lower substrate specificity. Then the another line gives you information about the direct links to the different type of protein database through which additional information can be derived. So this database like Brenda and XPASI and PDB, that is protein database, etc. You click over it and you directly reach to the protein database of that type, wherein you have additional information about this EC numbered enzyme. And finally, in the information which you retrieve is a list of references which says that who have discovered this enzyme for the first time, or who have analyzed it, studied it to a greater depth, or who have submitted it for the purpose of classification and naming, etc. So this type of bibliographic information is also available within the IUBMB database. Now, as I said, there are several classes of an enzyme. Every enzyme has been placed into one of these 6 classes, and the class is represented usually by the first digit of the EC number. And the first group of enzyme are all oxidoreductase type of enzyme. That means every enzyme having EC number starting with 1, that is number 1 at the first position, are all oxidoreductase type of enzyme. So in this slide I am going to tell you about what oxidoreductase are able to do. These are the enzymes which are able to oxidize one substrate, and this substrate which is oxidized is in fact a hydrogen donor. And the systemic name is, as I said earlier, derived by a structure called donor double dot acceptor and finally oxidoreductase. So this is a naming pattern applicable to all kind of oxidoreductases. A systemic name in case of EC1 type of oxidoreductase is derived in this manner. And also there are common names by which the enzyme is more popularly known. So oxidoreductase are also known by other names like dehydrogenase, and alternatively they are also known as reductase, maybe oxidase, because it is part of their one of the reactions out of the 2 they are catalyzing. But oxidase name is used only when final electron acceptor is the molecular oxygen. Now, all kind of oxidoreductase are further classified into different groups, and that is described by second digit. So this second figure, in case of all oxidoreductase, is describing a group in the hydrogen donor that is undergoing oxidation process. If it is CHOH group which is undergoing the process of oxidation, then the number is always 1. If it is CHO group, and then number is always 2. Likewise, the Enzyme Commission has given a list depending upon the group which is being oxidized in the hydrogen donor. The second digit of the EC code is generated. In the same way, oxidoreductase are further classified at a third level, wherein the third figure is selected on the basis of type of acceptor. If NADP is the electron acceptor, then the number is 1. If it is cytochrome, it is 2. Number 3 stands for molecular oxygen, serving as the acceptor. So this, in fact, code number itself tells a lot about the properties of enzyme. For example, it 4 simple digits, 4 simple groups of digit can tell you clearly about the type of reaction it is catalyzed, functional groups which are involved, type of chemical reaction, and the nature of the compounds which are taking part in the reaction. Everything can be understood simply by studying the digits only. Now, in the figure which is shown on the left side, you can see that oxidoreductase can be exemplified by a most popular and most commonly known enzyme, very widely studied enzyme, lactate dehydrogenase, which converts lactic acid into pyruvic acid by carrying out its oxidation. The second class of enzymes are all transferases, that is, all enzymes having EC number starting with 2 are all transferase kind of enzymes. As the name suggests, these are the enzymes which are able to, in fact, carry out transfer of methyl or glycosyl type of groups to the acceptor molecules. And in these type of enzymes, systemic name is derived by a pattern, that is donor to acceptor to group transferase. So write down name of the donor followed by name of the acceptor, and at the end we have to add group transferase. This becomes the systemic name for the enzyme. But common names are generally given by either acceptor or donor followed by group transferase as a suffix. Now, in case of transferases, donor can be coenzyme also, which is responsible for carrying out the transfer of group. And you know, all kind of transamination reactions wherein the amino group and hydrogen are transferred from one compound to the another one are in fact catalyzed by enzyme called transferase, which are commonly known as aminotransferase. A good example is that of amino acid oxidative deamination, which converts L-alanine into pyruvic acid and glutamate. L-alanine and alpha-ketogluteric acid are converted into 2 molecules of pyruvate and glutamate. So you can see that the amino group is transferred from one compound to the another one. In case of transferases, the second digit indicates the type of group which are transferred. If carbon group is transferred, then the digit is always 1. If aldehydic or ketonic group are transferred, then the enzymes falls within the group of EC number 2.2, etc. And likewise, there are series of numbers given, each one to distinctively identify a kind of group which is involved in the transfer process by an enzyme. Now, the third set of data, that is third figure, indicates the group transferred. If it is methyl transferases, then 2.1.1. If it is hydroxymethyl or similar type of formyl transferases, then it is number 2 at a third place, likewise. So this is how enzymes exemplified by alanine transferase belonging to group of EC2 transferase group of compounds, transferase group of enzymes is described. The third category of enzyme are all hydrolyses. Now this name is a tricky name because in the past the hydrolyses have been used in a distinctive meaning, hydrolytic cleavage of any substrate, especially in terms of CO bond, CN bond, CC bond, or any other type of bond. When it's cleaved in a hydrolytic manner, then the enzyme carrying out this type of catalysis are known as hydrolysis. The systematic name always include an ending by the term hydrolysis. The common names used for this type of enzyme is always ASE. ASE, that is enzyme ending with name ASE, are mostly hydrolase type of enzymes. This kind of enzymes are able to carry out hydrolytic removal of groups from the substrate, and maybe they are also able to transfer it to the another compound, and in that way they are very much similar to transferase of the group which we have studied previously. But looking at the physiological importance of the enzymatic reaction, where the involvement of water makes the basis for all forms of life, the importance of hydrolysis by the water becomes a very important aspect of enzyme catalyzed reaction, and therefore they are preferentially placed along with hydrolysis rather than along with transferases, although they does carry out transfer of compound, transfer of groups. Now second figure with the hydrolase type of enzyme is to denote that if it is glycosylase or esterase or so on, depending upon that the second number is given, whereas the third digit of hydrolases is derived out of the nature of the substrate. If it is carboxylic acid hydrolases, then it is EC 3.1.1. If it is thioester, then it is 3.1.2. Phosphoric monoester, then it is 3.1.3. Likewise, the good example of hydrolase type of enzyme is the one which cleaves the pyrophosphate molecule